Hello dear students, today we are going to start with the topic types of chemical reactions. We are going to see today four types of chemical reactions. The first one being combination reaction. As the name suggests, combination. Combination means to combine. So a reaction in which two or more substances combine to form a single substance is known as a combination reaction. For example, quicklime. Quicklime is calcium oxide. When it is put into water, it gives slaked lime, calcium hydroxide. So as you can see in this reaction, solid quicklime, it is mixed with liquid water, it gives an aqueous solution of calcium hydroxide. Two substances combine to form a single substance, and that is why this reaction is known as a combination reaction. Now there is an activity given in your textbook about quicklime. So let us have a quick look at a short video which shows the activity of addition of quicklime to water. Let us see what all the observations are, and then let us discuss again. Okay, so children, as you have seen the video, you have seen that on addition of quicklime to water, a lot of heat energy is generated. You had seen a container in which quicklime was put, in that water was added, and then suddenly you could see some fumes which were coming out. So the first observation is you saw bubbles being formed and there was a hissing sound, and you could see by the fumes that heat is produced. Okay, so let us see all these one by one. There are a lot of bubbles being formed. Now children, you can see in this equation there is no bubble, there is no gas being formed. Generally we can say that when bubbles are formed, it means that some gas is produced, but you can see from the equation that there is no gas which is produced here. Then can you think why the bubbles must have come? These bubbles, they are of water vapor, H2O, gas. Now as you know, it is producing a lot of heat. We can say it is an exothermic reaction. An exothermic reaction is a reaction in which heat is produced. So again, a lot of heat is produced and there was water inside the container. So due to that heat, what happens is all the water is getting transformed into water vapor. Because of that sudden release of the heat, water gets converted into water vapor, and as water vapor is in the gas form, So that gas will try to come out through the liquid water, and that is the reason why bubbles are formed. So these bubbles which are formed, they are not of hydrogen gas. Remember children, they are not of any gas, neither hydrogen, neither oxygen. These are the bubbles of water vapor, that is a gas form of water. Then you can hear a hissing sound. Hissing sound is due to the same reason, sudden release of the heat, sudden release of the gas, and you could see the fumes, which is indicating that lot of heat is produced. At the end of the video you had seen that the tremendous heat which is produced is even affecting that container in which the reaction took place. So that much amount of heat is produced. So this is an example of a combination reaction, and combination reactions are mostly exothermic in nature. Yes, we cannot guarantee that every combination reaction will be exothermic, but most of the reactions, they are exothermic in nature. Another example of combination reaction is burning of magnesium ribbon, which we have seen in the previous class. Mg plus O2 gives MgO. If we balance it, it becomes 2MgO. So this reaction also is a combination reaction. Two substances combine to form a single substance. So it is a combination reaction. And here also lot of heat and light is produced, as we have seen in the previous class. Okay. Then again, burning of coal, it is also an exothermic reaction. C plus O2 gives CO2. So solid coal is burning in the presence of oxygen. They are combining to form CO2 gas. As we all know that on burning of coal we get heat and light. So it is also an example of exothermic reaction. Okay. So we have seen the combination reaction. Here we have seen an example in which a compound is combining with another compound. Combination reaction, it can be of different types. Different types means there can be combination of compound with compound, or element with element, or it can be even a compound and an element. So here we have taken an example in which compound is combining with a compound. In this example we have seen element is combining with another element. Let us see one more example where a compound and element may combine. So this example, let it be SO2. SO2 gas, it combines with O2 gas and it forms sulfur dioxide gas. Sulfur dioxide gas reacts with oxygen gas and it forms sulfur dioxide gas. So this is a compound, this is an element, and we get one single compound. So this is an example of combination of compound with element. So here compound is reacting with a compound to give a single compound. Here compound is reacting with an element to give a single compound. And in these two cases, an element is combining with another element to give a compound. So these are all examples of combination reaction. Combination reaction means to combine. When two or more substances are combining, it will form a single substance. Now let us move on to the next type of reaction, the opposite of combination reactions. That is decomposition reaction. An opposite of combination, that is a decomposition reaction. So as it is an opposite of combination, decomposition means when a single substance breaks to form two or more substances, we will call it as a decomposition reaction. Means one single substance is there, and with the help of some energy, may it be heat energy or light energy or electric energy, we are breaking one single substance into two or more different substances. We call it as a decomposition reaction. Now just now I mentioned that we are providing some energy. This energy can be in the form of heat. We will call it as thermal decomposition reaction. So as the word therm itself or thermal itself indicates that heat is involved in this reaction. Means we are carrying out this reaction by providing heat energy, and that is why the name is thermal decomposition reaction. So how we will define it? We can define it as a decomposition reaction in which heat energy is used, or we can say that a reaction in which a single substance breaks into two or more substances by the help of heat energy or by the effect of heat energy is known as a thermal decomposition reaction. So the few examples which are given in your syllabus are, one is decomposition of calcium carbonate. So calcium carbonate, as we call it as limestone or marble. Chalk is also calcium carbonate. It is solid in state, and if we are heating, a triangle sign on the arrow means we are heating. It will give calcium oxide and CO2 gas. So a single substance breaks into two or more substances by the action of heat is known as a thermal decomposition reaction. Another example is heating of ferrous sulfate crystals. Ferrous sulfate crystals are green in color, pale green in color, and on heating you will get ferric oxide. This is reddish brown in color, and you will get sulfur dioxide and sulfur trioxide gases. Sulfur dioxide and sulfur trioxide gases, they are acidic in nature. So if we take a moist blue litmus paper near the mouth of the test tube, they will turn the blue litmus paper to red because they are acidic in nature. Fe2O3 has a reddish brown color, that is rust color. FeSO4 is pale green in color. So when we start heating this, what will happen? First, the water of crystallization will be removed because FeSO4 is a hydrated salt, and then the color of from pale green will start turning to colorless. On further heating, we will see reddish brown color of Fe2O3, means the pale green color, it became colorless, and from colorless now it started to form reddish brown color. And then gases evolved. These gases we cannot see with our naked eyes, but as soon as we will bring the moist blue litmus paper, it will change to red, which indicates that some gas is getting released which is acidic in nature. So SO2 and SO3 gas are formed. Another example is heating of lead nitrate crystals. PbNO3 twice. On heating, it will give PbO solid, which is pale yellow. This is colorless. And along with lead oxide, we also get NO2 gas and O2 gas. You can balance the equation yourself, children. Try later on balancing. After you see the videos, I will be sending you some points to write. So all the equations, whenever we are writing equations, you should balance all the equations, like you put here 2, you put here 2, you put here 2, you put here 4. So in this way the equations will get balanced. We have already learned how to balance equations. Again here, what will be the observations when we are heating? The colorless lead nitrate will change to a pale yellow color solid with a crackling sound. Now crackling sound is there because this does not contain any water of crystallization. Like FeSO4 contains water of crystallization. It does not contain, so it will crackle. Just like how NaCl also crackles. You can do yourself on your own. Like on a hot surface, if you put sodium chloride salt, it will start crackling because NaCl also does not have any water of crystallization. So it forms a pale yellow solid, and NO2 gas. This is important. It is a reddish brown gas. A reddish brown gas, nitrogen dioxide is formed, and another O2 gas is formed. So these two we can see with our naked eyes, reddish brown color gas. O2 we cannot see, but if we bring a burning splinter near the mouth of the test tube, it will burn even more brightly. So these are the observations of this experiment or this thermal decomposition. Now let us have a look at the videos, a short video of decomposition of ferrous sulfate crystal, thermal decomposition, and lead nitrate thermal decomposition.
Take the ferrous sulfate crystals in the test tube. heat it over the flame. Initially, the crystals decolorize as they lose the water of crystallization and turn anhydrous. The anhydrous ferrous sulfate then further breaks down into ferric oxide and a mixture of sulfur dioxide and sulfur trioxide. In fact, you will be able to detect the distinct smell of burning sulfur, but do not stay around for long since sulfur dioxide and sulfur trioxide are toxic gases. The decomposition reaction can be represented as 2FeSO4 gives Fe2O3 plus SO2 plus SO3.
Heating of lead nitrate, and we will classify the type of reaction. Materials required for this activity: white crystalline lead nitrate, Bunsen burner, dry test tube with holder, incense stick, and one spatula. Now let's do the activity. Take about 2 grams of the white crystals of lead nitrate in a dry test tube. Heat it over the flame, and care must be taken here. Tilt the test tube away from you to avoid fumes. Observe the heating process carefully. You can see that lead nitrate is producing a crackling sound along with brown fumes of nitrogen dioxide. Let's burn the incense stick, and let's put glowing stick inside the test tube, and you will see that it reignites.
Okay children, so all of you have seen the video, and I hope that you have understood properly whatever I have explained through the videos, and I hope so you have also enjoyed seeing those videos. Now let us move ahead. This was thermal decomposition. The second type of decomposition reaction is electrolytic. Electrolytic decomposition. Electrolytic means with the help of or by the means of electric current. So we are using electric current to carry out the decomposition reaction. So here let us understand this with the help of electrolysis of acidulated water. So we have a plastic mug. In this plastic mug we take water, and this plastic mug is drilled at the bottom, and then there are two rods which are inserted. These rods are made up of graphite, and then these are connected with the anode, cathode, battery. Okay, then there are two test tubes which are taken. They are also filled with water, and they are inverted on these two electrodes, and then some few drops of concentrated sulfuric acid is added. This is test tube. This is a plastic mug. And this is a battery. Now we are passing electric current for some time, and then we will observe what will happen. But before we understand this process of electrolytic decomposition of water, we need to understand what electrolysis means. So let us see what is the meaning of electrolysis. Electro means electric current, with the help of electric current, and lysis means breaking. So electric current can be carried in a solution with the means of ions. It means, in short, that current can pass through a solution only if it is having ions. Here we are taking water. Pure water, as we know, it is a bad conductor of electricity. Pure water, it is having H plus and OH minus ions. But these ions are not sufficient in number to conduct electricity. So that is why we need to add some few drops of concentrated sulfuric acid, few drops. And actually this is water. And in the water we are adding concentrated sulfuric acid. It means the water becomes acidic. Now what is the purpose of adding this concentrated H2SO4? Because pure water is a bad conductor. To make it a good conductor or to provide it ions, we are adding some concentrated sulfuric acid so that it gets more number of ions. Now when we pass electric current, the two types of ions, that is, this is cation and this is anion. Cation is a positively charged ion. We'll remember it in this way, cation. So the positive charge itself is in the spelling. And anion is the other one, that is the negative ion. So cation will move towards cathode. Home of cation is cathode. So if cation is positively charged ions, means cathode will be negatively charged. Opposite charges attract each other. And same way anion will move towards anode. So if anion is negatively charged, anode will be positive. The bigger line indicates positive electrode, smaller line is the negative electrode. So this will be the positive electrode, this will be negative. This is anode and this is cathode. Now when the ions, on passing current, the ions start moving, on moving to the electrodes, they go and touch the electrodes and they get discharged. Means the charge on hydrogen ion or the hydroxide ion will get destroyed and the corresponding element will form. So at cathode, hydrogen gas will form and at anode, oxygen gas will form. But we don't know which gas is formed. We can only see that the water will be dislocated or there will be a downward displacement of water inside these test tubes. You can see in this way that small portion of empty space. Empty space means the gas is collected here at anode and that at cathode also, but you can see the volume here is less as compared to this. This is double in volume as compared to that which is collected at anode. When after passing electricity, after some time, we remove these test tubes and then we check the gases by bringing a burning splinter. Hydrogen gas, it gives a pop sound because it is a combustible gas, and O2, it will support combustion, means the splinter will burn even more brightly. So this is the test for hydrogen and oxygen. Let us have a quick revision of all these things, whatever we have seen, with the help of an activity.
Electrolysis of water. If electricity is used for decomposing a substance, it is called electrolysis. When electricity is passed through acidic water, it decomposes into oxygen and hydrogen gases. But water is a bad conductor of electricity. Therefore, a little salt or a little alkali is added to water for easy conduction of electricity. Dissolve a little quantity of acid in water. Pour the solution in an apparatus as shown here. Fill 2 test tubes with solution and see that no air bubbles are present. Invert these test tubes over the iron nails. These are called electrodes. Connect these outer electrodes to the positive and negative terminals of a battery. You can see that gases are produced in the 2 test tubes. After 30 minutes, examine the volume of each gas formed in the test tubes. Are the volumes of gases equal? Introduce a glowing splinter into the test tube in which less amount of gas is formed. The splinter burns brilliantly. Therefore, we can say this gas is oxygen. Introduce another glowing splinter into the test tube in which more volume of gas is formed and observe it. This splinter is put out with a pop sound. But the gas burns with blue flame. Hydrogen possesses this property. Therefore, we can say that the gas present in this test tube is hydrogen. In this way, sending electricity through water and decomposing into oxygen and hydrogen is called electrolysis.
Okay children, so you have seen this same activity in the form of a video. You have understood in a more better way. Okay, let us go ahead with the next type of decomposition. The next type of decomposition is photolytic or photochemical. Photochemical decomposition. Photo is light. So that type of decomposition which takes place with the help of light is known as photochemical decomposition. Here let us see the example of silver chloride. Silver chloride is a white color solid and it is exposed to light. If it is exposed to light, it turns grey in color after some time due to the decomposition which takes place. AgCl gets decomposed to form Ag solid, that is silver is formed, and chlorine gas, which is a yellowish green gas, very pale yellowish green, even not so much observed with our naked eyes, that is released. Similar example is AgBr. It is also exposed to light. We will get 2Ag plus Br2. Both these reactions are used in photography, black and white photography. Children, now it is a age of digital photography, right? So you must not be knowing, earlier there were cameras, and in the camera we used to feed the roll and we used to click pictures. So in the black and white photography, you must be having some pictures of your grandfather, grandmother, or their parents, grandfather's parents. So you can come across some black and white photographs. So in developing those pictures, these reactions, that is decomposition of silver chloride and silver bromide, it is used. You must have seen in some movies also there is a dark room in which the photographs are developed. So that is in those days such type of photography it was done. Okay. So this is all about photochemical decomposition. So we have completed with two types of reaction, combination reaction and decomposition reaction. In decomposition reaction, we have seen thermal decomposition, we have seen electrolytic decomposition, and we have seen photochemical decomposition. I hope that till here all the things are clear.
Let's carry out a chemical reaction that occurs under the influence of light. We mix dilute solutions of silver nitrate and sodium chloride. An insoluble precipitate of silver chloride forms. We filter the mixture using a filter paper and funnel. We wash the precipitate with distilled water. Then take the filter paper out of the funnel and spread the precipitate out over it. We put an object on the filter paper to cover part of the substance. We transfer the whole to a well-lit place. After a few minutes, we remove the object covering the filter. The area previously covered by the object has not changed color, whereas the surface exposed to light has darkened visibly.